In the example 2, we have a 10-kilogram bar is fixed on the carriage at A. So obviously we can see that we have a cylinder that's going to be sliding over this carriage toward the bottom. So we need to remind the internal axial force, the Ny, the shear for Vx, and the moment Ma at the point A. If the carriage is descending the plane with the acceleration of 4 meters per second square. So first I'm going to show you the free body diagram and the kinematic diagram for this scenario. So you will see that we're going to consider that this is the x-axis, this is the y-axis, and rotation around the z-axis. The free body diagram is just the bar, okay, have the center of gravity in the middle. The total length is 2 meters. That means it's going to be 1 meter from the point A to the point G. The forces we are going to have at the point A is going to be horizontal force AX and the vertical force AY. And we have the MY around the point A. That's the free body diagram. Now we go into the kinematic diagrams, where is that we're going to have the mass multiplied by the acceleration is going to make it as a force. So the force is going to be going to from the center parallel to the sliding angle. So we're going to have that the MA is going to have MAX and MAY. You can see that both is going to be negative because this one is going to go downward, this one is going to go to the left. We can find this angle to be 30 degrees because this angle is 30 degrees, and we're going to make simply the simple analysis for the angles, and that's something actually I found that many of the students have a problem with. So this angle is going to be 30, so I can say that the MAX is going to be the MA multiplied by the cosine of 30, and the Y is going to be multiplied by the sine of 30, both negative. So once again, let's start to do the solution. First, we need to do the free body diagram, and the kinetic diagram of the bar are going to be drawn first. I have a look on this one and come back to the end of class to ask me a question about how we done that. So we are going to have two bodies. Focused body is going to be the bar. Translation movement, which is going to be rectilinear. We need to find the Ny, the Vx, and the Ma are going to be the internal forces on the bar, and they can be used for strength, the analysis of the materials in the design. So what we know is that the mass is 10 kilogram and the acceleration g is 4 meters per second square. Okay, so we know the acceleration at g, the acceleration at that point that's going downward. So we can take it to two analyses, the x direction and the y direction. You can see that both are going to be negative value because, well, I need to use my pen to show you that the direction of that is going to be going to the left, so that the AGX, okay, and that is going to be the AGY, which is going downward, and that's why I'm making them both negative value. Now, the next is the unknown. What we have is we don't know what the force X in the X direction and the force at the point A in the Y direction and the moment around the point A. So simply, if I'm going to do that, I need to do the equation that the force in the X direction is going to be equal to the mass multiplied by the acceleration in the X direction, and the force in the Y direction is going to be equal to the mass multiplied by the acceleration in the Y direction. And the moment in the free body diagram is going to be equal to the moment at the free body in the kinematic diagram. And to do that, we can simply going to use the forces that we have that cause the moment around the point. So here we have just the moment A because both these forces are going to be acting directly at that point, and this one is going to have no action. So once again, none of these forces causing any moment on the free body diagram, while here this force is going to be perpendicular to the distance to the point A, so we need to find that length multiplied by the mass multiplied by the AGX. and we will find the moment around the point A in the kinematic diagram. So that will be the solution. These are the three equations we're going to use. We always going to use this equation to do the solution. So we start with the step number one, that the sigma of the forces to the x-axis in the free-body diagram is going to be equal to the mass multiplied by the acceleration to the x direction in the kinematic diagram. And this should be easy because we know the mass is 10 kilograms. We multiply it by the AG x, which is the minus 4 multiplied by the cosine of 30, and we can find the answer. So that's what we have. Now, just the AX is going to be unknown, which is going to be equal to minus 34.6 Newton. Now repeat the same process for the y direction, sigma of the force to the y direction. And now here we're going to have both the force at the point A that's going perpendicular and the weight which is going to go perpendicular downward. So again, a positive, negative, and on the other side we're going to have the mass multiplied by the acceleration at the point G, that in the x-axis, which is going to be also a negative value. So the equation on the other side is going to be two components on the left and one component on the right. And by putting it all together, the only unknown is going to be the force A and the y direction. So solving that, I can find that the AY is going to be 78.1 Newton. That's what's straightforward. I hope we're going to have all the questions to be as that simple. But anyway, if you don't understand the concepts, you're not going to be able to do the harder questions. Now, finally, we're going to do for the moment. So we said once again that the moment we have on the free-body diagram should be equal to the moment we have on the kinematic diagram. So the moment on the free-body diagram is just the MA, which is unknown. And in the kinematic diagram is going to be equal to the mass in the x-axis multiplied by the distance from the point G to the point A. So we're going to put that together. So the mass is 4 multiplied by, sorry, the mass is 10 multiplied by the acceleration of 4 multiplied by the distance GA, which is 1 meter, multiplied by the cosine of 30 is going to be equal to 34.6 Newton meter. And that will be the moment we're going to have around the point A. Okay, so see you in the next question.